Assalamualaikum and good evening to lecturer. My name is Muhammad Dina Hakim bin Azhar. My matrix number is B08 2010236. For my part is oscillator 1. Firstly, we have to do the calculation. For the calculation, I assume the C is 1 nano. So the C1 and C2 is also 1 nano. Second, this is the formula for find the value of R. So equal to 1 divided by 2 pi Fc. The and the frequency is 1k and the C is 1 nano. I get the calculation is 159.2k, but I use 158 in the simulation. So the R1 and R2 is 158 also. And the third calculation is to calculate the frequency. The formula is Fr equal to 1 divided by 2 pi Rc. So 2 pi R we take from the calculation above 158, and nano in capacitor we use 1 nano. I get it 1.005 kilohertz, but I use 1k because the requirement we have to use is 1k. And the next calculation is gain formula to calculate the RS and RF. For the formula is AV equal to 1 plus RF divide RS. AV equal to 3 and equal 1 plus RF and RS. And this is the calculation. Let's say the RS is 30k. For find the value of RF, RS 30k must multiply by 2 because RF is 2 times the value from the RS. So the 30k multiply by 2, I get 66k, but I use 98k. This is just a small note for me lah. For the gain of oscillator must be around 3 so that oscillation to be sustained. If the gain is less than 3, the oscillation will fizzle out. If the oscillation more than 3, the oscillation will produce the distortion. So this is my circuit that I designed. I will show you through the multisim. This is the circuit. I use diode because I want to prevent the distortion for the circuit. So this is the RF. The value is 98k ohms. This is RS 33k ohm. VE and VCC I use 15 volt. This is R2. R2 is 158k, C2 1 nano, C1 1 nano, and R1 is 158k. So the result will be this is the result. I get the The frequency 1K and the peak to peak is 1.38 volt. That's all for oscillator 1. Thank you. Assalamualaikum. My name is Muhammad Din Hakim. For this part, I have done the rectifier part. Full bridge rectifier. Uh, let's say I put the C is 1 UF at the output of the rectifier as a filter. So the calculation is take the VBP from output of active LPF. The VBP is 1.39 volt. The VP is 0.695 volt. The VRMS is 0.707. And VP we have to calculate VRMS multiplied by the VP. So the calculation result is 0.491 volt. So this is the circuit that I designed. So I will show you the multi-sim. And this is the multi-sim. As you can see, this is the full bridge rectifier. This is C1 and this is R1. For the power supply, I have set the VRMS like in the calculation. The VRMS is 0.491 VRMS, and I will run it. As you can see, the result is I get the result like this, and that's all from me. Thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Rabi Abdullah, and now I'm showing the assignment for electrical system low pass filter part. For the last low pass filter, we must the frequency be 8 kilohertz and the circuit must be second order. So now, by assuming the R is equal to 1 kilohertz and using this equation and applying the information R1 and 8 kilohertz for the frequency, we can get the temperature, which is what I get is 19.89 nanofarads. For the resistor, I assume the RA is 586 ohm, and as I said, the circuit must be second order, so we can get is the R1. R2 is must the it's 0.586. So I assume the RA is 586, and using the equation I can get the RP, which is 1 kilohertz, and the RA is 586 ohm. So by using the result here, I made this circuit for the last low pass filter equation with the input and the R1 and R2, which is 1 kilohertz, and RA is 586, and the RP1 and the capture, as you see here, is 19. Right. So I use it, and by using this to get the output, so let's run. As you can see, the line is changing. The changing line is almost in 800 kilohertz as the assignment asks, like 8. Okay, see, okay. This here is our output, and that's all from me. Thanks.
Okay, Assalamualaikum. My name is Amir Rashid, and today I would like to present my part, which is the oscillator. So as you can see right here, this is my calculation for second circuit, which is oscillator. So I assume for the capacitor is 2 nanofarad. So, and then we find the value of R. So we using the formula to find the R, which is 1 over 2 pi fc, and then the result that we get is 3.998 kilo ohm. So we assume we using for simulation multisim, which is 3.4K, which we use on multisim. And also we use for R, represent for R1 and R2. And then after that, we recalculate back to make sure that we get the same value for the previous one. So we using the formula of FR, which is 1 over 2 pi RC. So we using the value of R, which we get right here, and then we get the value of frequency to 33.4 kilohertz. And then we now find the formula gain to calculate from RS and RF. So this is the formula, which is 1 plus RF divided by RS. So we get that A gain is 3. And now, let's say we assume for the RS is 48K. So then we get the value of RF is 96 kilo ohm, which we assume for the simulation is 98K. And now to the simulation, as you can see, this is the circuit for the oscillator 2. And now I will start run. So as you can see right here, the frequency is get almost same as the previous calculation, which we get 23.4 kilo, which almost the same as the simulation. And now on to for the next part is the summer circuit. So in for the summer circuit, the objective for this summer is to combine the multiple input into one output, which is we we been creating two input, which is oscillator 1 and oscillator 2, combine both of input into one output. So for the first oscillator were created by Daniel, and for the oscillator 2 circuit was created by me. So I will combine both of the input into one output. So this is the calculation to find the R, to find the V out, which is the output of voltage. So we assume that RF is equal to 1K. So and then the final result that we get is 1.322 volt. And now let's take a look for this simulation. And now this is the simulation that we have combined two, which this is my part and this is Daniel part. So I combine both input into one output. And now let's test the simulation. see right here. And now let me adjust it for a second. All right, so now let's take a look for the channel 1. So for the channel 1, we got the output value is 1.38 volt for the first input, first oscillator 1 circuit. And now for the channel 2, we got 1.27 volt for the oscillator circuit number 2. And then for the last part, which is the output of combining of two input, we will get 2.62, which is divided by 2, that we get 1.32. So the value that we get almost the same, the value of output that we calculate. And now I will pass to the next partner. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Darda Naufal, and today I want to present about the voltage regulator. So I have been given the assignment to construct a voltage regulator. And what is voltage regulator? So a voltage regulator is a circuit that creates and maintain a fixed output voltage. So for me, the assignment that I've given, I have to specifically construct another voltage regulator that is a shunt voltage regulator, as you can see here. So this is the circuit that I have construct. So the circuit voltage regulator get an continuous input from another circuit that is a rectifier circuit that is down here. This is the rectifier circuit that we will be using. So what is a shunt voltage regulator? So the shunt voltage regulator is a type of voltage regulator that is designed to shunt the current to the ground. So any current that is dissipated will be shunt to the ground. So there is a diode here. So the function of the diode is to shunt the current that is from the rectifier circuit. So any excess current will be shunt to the ground, and we will use this transistor and also the amplifier to amplify the voltage of the circuit. So the output that we'll be getting will go through R3. So output voltage that I get is from the measured circuit is 4.917 volt. If you can see my calculation, here is my calculation for the voltage regulator, shunt voltage regulator. So as you can see here, this is the voltage output. So we want to find out what is the value for Zener diode, the voltage that go through Zener diode. So we have VO 1 plus R4 over R2. So we get the result here, that is the voltage that go through Zener diode is 2.5 volt. So that is the output that we get. So the assignment said that I have to get the output in 5 volt. So I have the almost the same value, that is 4.917 volt. Thank you.
Assalamualaikum and hello. Today I would like to present my part, which is the load circuit and the combined circuit for our project. And first of all, I will show the calculation for the load circuit first. So to get the resistor load, we have to use this formula, which is we derive from the power load formula to get the resistor load, which is we get voltage load power to 2 and P load divided by P load. So given P load is 1 watt, while voltage load that we use is 4.917 volt. So from that we will get 4.917 power to 2 divided by 1 watt to get the resistor load, which is 24.18 ohm. So let's proceed to the simulation. For the first one, I will show the load circuit of load. So we can see the voltage here is 4.917 volt and the resistor load 24.18, just like the calculation, kilo ohm. And so we will run it. So we will get 1.451 watt, which is we accept it because it's near 1 watt. This is okay. So let's proceed the combined circuit, which is I will combine all the circuit from this project that we assigned to. So this is this one is for the circuit of oscillator 1, oscillator 2, summer, rectifier, and the last one is for the voltage regulator. So I will run it. So for the wattmeter reading, I will get 1.22 watt, which is near to 1 watt also that we required. So this is the result of the experiment after we combine all the circuit. I think that's all from me. Thank you.
Now I will talk about the deciding for our assignment. Uh, we may examine how an oscillator convert DC signal to AC signal by summing the voltage amplifier output signal, a circuit that creates continuous repetitive waveform without any input is known as an oscillator. Then by increasing the bandwidth of the filter, we employ to an active low pass filter to adjust the frequency response and provide more selective output response. A transition from a low pass to high pass filter is called an active low pass filter. A rectifier is a device that transforms a two-directional current AC sig- into signal directional current DC. A voltage rectifier also used to convert an AC signal to a DC signal, which is required by operating system. Finally, the rectifier output signal was sent to rudimentary shunt voltage regulator, which controlled the output voltage by shooting current away from the load. In the conclusion, the project was given based on a block diagram, and that we must complete six circuits, which will be combined in the final stage of this project by employing two oscillators to make continuous waveform without any input. In this project, an active low-pass filter is utilized to change the frequency response by convert a low-pass filter to a high-pass filter, resulting in a more selective output response. Aside from that, after low-pass filter settle, a rectifier is used to convert an oscillating two-directional AC current to a single-directional DC current, and voltage regulators are used in this project to supply the power for output voltage, and we can get every reading for frequency each circuit, and the whole circuit is the same with the calculation that we make using an oscilloscope. Finally, deploying a software multisim for this project allow each member of the team to, to collaborate quickly in order to address problems that arise as well as to discover and correct errors. And that's all.